That's my presentation, Fear and Loathing in Telecoms. And I want to focus on something that has been under-researched in terms of how attackers leech money of telecom operators. Well, there are actually companies in Russia that try to sell their IS services to telecom operators. Could be IS audits, for example, and for some reason they're only focusing on technical issues. But interestingly, when these guys talk to the operators, they say, well, we can intercept your text, or we can intercept a call. The operator will say, well, it sounds interesting, but is that really dangerous? We're losing money there, are we? Well, if your subscribers' calls get intercepted, that will certainly damage your reputation, but not that much. Let me first, though, tell you about the technical things everyone, I believe, should know. That is, I will be talking about the technical attacks against the telecom networks. We'll talk a little bit about femtocell abuse, fake base station attacks, attacks via GRX, IPX networks, SS7 location, SMS interception, and call interception. At the Moscow DevCon, Kaspersky guys had a great story recently about femtocell attacks. I'm actually providing a link here to their presentation. So a femtocell is essentially a small gadget like a Wi-Fi router that anyone can buy, install in his flat or office to route mobile traffic. Now, you might have heard the story of Natalia Kaspersky announcing a new service where any company can actually eavesdrop on all the calls going through the femtocell. Well, this sounds bad. This is being discussed a lot. From what I know, InfoWatch did not really develop the hardware, if you like, or the software for the system themselves. So Kaspersky Labs started the femtocell not for this purpose, but rather in order to do reverse engineering, in order to learn more about the traffic going through it. They were also able to get access to the IP data, because essentially it's a security gateway for the operator. Any femtocell will connect through a VPN concentrator via an IPsec tunnel. So they were able to get access beyond the IPsec tunnel. I don't really know how they did that, because they didn't really disclose it, but what we are interested in is their SS7 attacks. And their traffic will be routed to HNB gateway. The majority of attacks against SS7 network requires particular requests to be allowed, and HNB gateway in most cases will block this request, which obviously reduces the, well, not the attack surface, but the frequency or probability of such attacks. Having said that, let's look at how it happens. Another attack is pretty old. So what you do is build your own fake BS. BSs are easy to buy. So you have your own laptop and a stack of open software. Then you fire up a GPRS or Edge and you start handing it out. It's a pretty complicated sort of attack because most operators have pretty dense coverage, meaning that very few guys actually offer GPRS. Most of them do 3G or LTE, and in these frequency ranges, there will be other issues. So we can consider it either an academic case or a sort of feasible case for poorly covered areas. So users will get connected to it, and you give them access to the internet via your stack. And this enables you to do your regular MITM. So essentially, you do the same stuff as you would do in a regular Ethernet MITM. And if we have somebody who is smarter, he can actually start sending voice through the same cell, through the same base station. That requires changing the default settings. And then you can eavesdrop on the voice calls. Moreover, you can automatically analyze this voice data looking for keywords. Let's look at a different attack. This one against GRX. So this is Global Roaming Exchange Network. This is the network that our internet traffic goes through when you use mobile intranet. In roaming, that is, when you're traveling. So all telecom operators are part of this network. So whenever you access the internet overseas, your internet traffic will be routed through this network. It's an interesting vector of attack. In order to mount an attack, you need to be inside the network first, and this is quite difficult. So the configurations I've seen are regular IPsec tunnels leading to the GRX hub. So you won't be really able to read external traffic. Usually it's the big operators who are part of the GRX network. But if you have access to the GRX network, you can come up with a feasible attack. But I haven't really seen successful attacks of this kind performed publicly, so to speak. And I don't see it as a significant vector of attack for an operator, therefore. Another one is a SS7 location sort of attack. Guys from Positive Technologies have already talked about this one. It's in fact a pretty well-known vector of attack. You can mount this one when you have access to the SS7 network. Then you can locate a particular subscriber using a couple of SS7 requests. So you initiate a text or a call, and the network will tell you which particular switch this user is connected to. So all switches and all the other equipment are registered in the database. The database is publicly available. The same is true for the location data. So you can see in this picture how guys were able to identify the location of a particular subscriber, well, in the vicinity of a particular base station, obviously. Well, again, this is an attack against a subscriber, which means that the operator, the carrier, doesn't care that much. I mean, they would want to mitigate those threats, but not very much. They wouldn't be passionate about it. SMS and call interception in SS7, again, Positive Technologies people have already covered this one. If you have SS7 access, you can intercept text. So they have their own variation of MITM. When attacking the well, you essentially represent yourself as something you're not. So you can intercept calls, you can intercept SMSs like this. It's not easy to mount, but it can be done. Again, know that this is a subscriber targeting attack, which means that the operator, the carrier, doesn't have too many incentives to protect against it. Let me switch now to the main part of my presentation, where I'm gonna focus on the things that the carriers really care about, because this is where they can lose money. Meet Boris. Boris is a very active, not so young person who knows a little bit about operators, and he is going to perform all sorts of interesting arrangements or attacks. Now let's distinguish between internal and external schemas or crime vectors. So this suspicious activity can be located either inside the carrier's network or outside it. Outside it, it could be a violation, for example, of the roaming agreement. Inside the network, there will be many more potential cases that we will look into. We shall start with the external one. So what we're showing here is that we have a Russian operator and, say, a European operator. So they have an agreement on billing each other for roaming traffic. And a roaming operator will undertake to use this particular sort of, it's a kind of an exclusivity agreement. So if a Russian tourist stays, say, in Europe and then calls his family in Russia, the European operator will undertake to send this traffic via the home operator, not some other operator. And that will cost everybody $10. But you do understand that sometimes they don't feel like doing it. It might cost them $10 to send this traffic. Now, this is where Boris comes in. Boris says, "Hi, I know you're getting loads of tourists and they all call home. And you must have heard already, I've heard that you pay $10 per minute, and the carrier agrees this is the case. Well, I propose the same kind of service, but it will cost you 10 times less." Greed is a strong motivator. So some can actually sell their owner for $1. So Boris will then send his traffic to Moscow, and the EU operator will send the Russia-bound traffic through Boris instead. Actually, discovering it with modern anti-fraud systems is pretty easy. And Russia's leading carriers react violently. Actually, whenever they see that something is suspicious, they will disconnect Boris right away, making Boris significantly less rich. But it used to be a profitable business. For Boris, that is. Let's look now at internal threats. Let's start with sim boxing, as possibly the most well-known sort of activity. Sim boxing is when you buy specialized equipment. It's already available in the market. You can easily buy a gadget like this. Then you put into the SIM box the SIM cards you bought from a different operator. Let's look at case number 1. You have several SIM cards, say 30 SIM cards from operator 2, that is located in a different country. And then you can advertise traffic to that particular operator for $1 per minute. While calling the same country legitimately will cost people 10 times more. The way it works is as follows. Boris, the perp, who is physically inside the country, is paying the local rates. And that gives him a pretty nice profit margin. Because he can have a SIP or a non-SIP connection with operator 1, so he doesn't pay a lot. Let's look at a slightly different case. You can have, for example, unlimited calling plans, and then you will be calling to any operator whatsoever, because you have unlimited call plans. In this case, you get higher profit, but then you'll probably have more issues. Again, it's very easy to discover ploys like this, because their systems will show that a small number of SIM cards is generating a lot of traffic. However, legislation can be different in different countries. So what can happen, for example, that a carrier will block a SIM card but will not actually be able to sue the perp. So what the perps do, they simply obtain new SIM cards. So this particular technique in many countries is still viable. I'm sort of inviting you to try it out, but do remember, it's criminally not okay. Let's look now at stuff that's slightly more complicated. I'm about to tell you how carrier's billing is structured. Shown here are network switches, where calls from other operators land. In the center, the data will go through additional transformation. For example, if you, some customers, some subscribers will be postpaid, others will be prepaid. And billing for them, obviously, will be done differently. Then billing system will put everything into DWH, a data warehouse. For example, 3-month-old data, nobody needs it really, so it will go back, it will go straight to storage, I'm sorry. Some data will go into the ERP system. Most interesting stuff goes to the payment gateway, because this is where settlements with other operators are executed, and settlements with other parties interested in our money. Report generation, discounts, they all happen there as well. We don't care about them though. You can actually learn more if you follow this link. Let's look at particular attack scenarios or crime scenarios. Hiding from billing. So Boris, in this case, is an employee of the operator. He could be a manager, but not necessarily. Or maybe he knows somebody who works there, and he invites this person into sharing his profits. So Boris's idea is as follows. It says, let's establish a link. Like, I have my own company, a small telecom operator. We'll establish a link now between the two operators. And you will mask inbound traffic from me, camouflaging it as yours. What this means is that Boris will find subscribers, they will pay him money, they will make calls, but operator 1 will end up paying for these calls. It's pretty easy to perform, really. All you gotta do is connect one more cable in his server room and do a bit of setup as well. Such an arrangement can be discovered if you do financial analysis. If the operator is analyzing the evolution of calls, they should be able to see that they're actually paying money for, say, overseas calls, but when they're getting paid for them. Large operators have what they call yield. Effectively, they have agreements with other operators that say that they kind of promise a particular volume. But you should remember that it could be enough to make for a pretty comfortable life for 2 or 3 people, but you can't get obscenely rich with it or you will get noticed. Operators obviously will do sort of customary among the operators to not care about deviations of 3 to 5%. So if you keep a low profile, if you do not get arrogant, you can actually stay below the radar. Now I'm guessing that many people are actually living off a scenario like this quite nicely. But again, they're not filthy rich. Let's look now at a more complicated scenario. What's interesting about it is that while in the previous one we masked the outbound traffic, in this one we will be hiding the incoming traffic. So Boris or his friends are working for operator 0, shown in the cloud here. It could be a local operator. Inbound traffic to the phone numbers of operator 1. He's inside the network, right? It's inbound traffic. We don't pay for it, right? Which means that the magnitude of what you do will only be limited by your greed. Because nobody pays, I mean, the victim doesn't really pay for this traffic, and the way the equipment is set up, this stuff will not get noticed. What's also interesting about it is that the anti-fraud systems, even if this data actually goes through the anti-fraud system, most anti-fraud systems are not taught to actually discover it. Let's look into the technical details. The mediation system I mentioned previously will translate the information coming from switches into billing data. So we're showing here individual user level. So when a user makes a call, CDR is generated. Well, CDRs here are called UDRs. UDR data goes into the mediation system, and amalgamated or transformed data goes into the billing system. Shown on the right is the example of such data. It's an XML. We have VSH code in it. You can easily compromise it. You can, for example, change the kind of the codes that apply to either the rate plan or the trunk numbers. So you can easily swap the IDs. And that way, traffic coming from some suspicious location will be identified as the traffic coming from a well-known operator, so that he will have to pay for it. Moreover, you can delete this data. You can actually state that all call data coming from this trunk or these numbers will not be contributed to the billing system, will be simply deleted. Moreover, some billing systems are set up in a manner that make sure that whenever they get CRs or UDRs that don't have trunk IDs, they won't process this information, so nobody gets billed at all.
Да, и, соответственно, вот эта схема, она достаточно несложно реализуется при известных.
And this is a pretty easy to pull off scenario if you know the right people, and it's very difficult to discover. Because your anti-fraud systems will not be able to discover it, because it's not interested in attacks like this, while all the interested parties could be bright.
Вот такие схемы, достаточно интересны, на мой взгляд, большинство из них реализованы. То есть, если
Now, most traffic looping. Shown here is a simple technical loop. So an incoming call is bounced to a different operator A, who for some reason will return the call back to our operator. And our operator sees an incoming call and returns it to A. It's a regular technical problem. So if you do that, you can easily get a DOS because you jam up the channel very quickly. Well, this is where you can actually make money, because here you have three operators. We have the victim operator and operators A and B. In order for this stuff to be workable, rate plans should differ. Inbound calls for A should cost more than outbound calls from A. And that's what we're showing here. Operator is pay A S1, while A pays B S2, while B pays operator S3. And as we're showing here, S1 is the largest payment. This is the way it works. And Then operator B will return this call to our victim operator at an even lower price.
Оператор Б и наш оператор это одна группа компаний, такое часто бывает, например.
Actually, some of these operators can be part of the same company. Some big telecom operators work around the world, and operator B can easily be a subsidiary of a victim operator in another country, and in this case, S3 can be very close to 0, because they're part of the same family. It's actually quite difficult to discover scenarios like this. Because a number can easily change and will be difficult for us to track the call. So it has been looped and we won't even know whether it's the same call initially or not. So even a good anti-fraud system can be useless. CDR example. We see 3 lines there. One corresponds to a call that was made. And the calling number started with 7 and they came from trunk 1 to switch 0. And it was redirected to operator A from switch 0. This is our S1 here in the chart. Then operator A sends it to operator B. We only have limited information here, which is duly shown here. Our CDR log doesn't show it. And next we see an incoming call from operator B. So we see it's the same calling party. But you'll see that the trunk ID and the switch ID are different now. And since we care so much about the price, we send the call again to operator A, thereby closing the loop. Actually, after that, operator A can redirect the call to a different operator, not B, and that way you can go through several loops and you won't even know that. Such an elegant scheme, really difficult to discover, but operators are trying to fight it. This is it for me. We actually know a lot about existing attacks of that kind. That way, the operator, the carrier, will have to pay money right away. But it's difficult to monetize it in any other manner. Was it for a purpose that you didn't mention the type of incidents where user equipment is compromised in order to send traffic to a variety of expensive destinations? This is how you can bankrupt a telecom operator. That's true, sure. So it can easily happen that a corporate customer's equipment is compromised, and then billion worth of traffic is pumped through it. So everybody loses, right? I did mention it, that's right. Well, because actually the losses there are colossal compared to the losses from scenarios you've described. Oh, I'm sorry, I should also give you a t-shirt. I've got two. Thanks for your report. So you talked about some Boris who could do sim boxing. And I'm wondering what will keep Boris from having several SIM boxes and separating the traffic so that nothing is suspicious. Nothing. Now, if the amount of traffic doesn't trigger the alarms in the anti-fraud system, he's pretty well protected. So if he's not arrogant, if he's not too greedy, he won't get caught. But the way it works is that calls go through the SIM cards all the time. So much will really depend on the setup of the anti-fraud system. There's also a trans-border transmission case, right? Where you have Boris in a different, but in an adjacent territory. And that way, if he uses a narrow focus antenna to actually get signal from a different country. So formally, he's physically outside the country where he bought the SIM card. Oh, that's an interesting vector. And I think that modern SIM boxes can already call each other, and they can easily dupe, by doing that, the older anti-fraud systems. Can you please go back to your triangular schematic? How can S1 be bigger than S3? I don't think I will be able to sell a transit call at a price higher than what I'm paying. And if it's a loop, somebody will have to terminate a call, otherwise nobody will get paid. So how do I know when I will start monetizing it? DOS is a separate case. We are not discussing it. We are trying to monetize the call here after all. So operator A gets an inbound call. If this call is not supported, so to speak, nobody will get money. Indeed, I should have shown the call termination here, the second leg, so to speak. I actually believe it's hugely complex, this arrangement you're showing. Now, it requires a lot of insider information, where you have links that are below their capacity, so to speak. Well, the simple case is when you have operator 0 and operator B that are part of the same family. And it's sort of easy. If they're friends, they know a lot about each other. Other questions, please?
По поводу антифродного звонка все понятно, всему 100 лет. Что там нынче у телекомов по поводу антифрода на СМС?
What about anti-fraud for SMS? Do you mean suspicious SMS campaigns? No, I mean the ones that have phone numbers or contact details or contact links. What I know. is that the recent hacks of Telegram involved SMS confirmation. If you have access to SS7, you can intercept data. Is that what you're talking about? No, it's a different case, I'm wondering about. Take SIM boxing or SMS banking. Rather than initiate calls, we can land the text, thereby selling SMS-based authentication. I don't have any data on that. Thank you. Is that it? Okay, thank you very much. I'm handing over T-shirts to the two gentlemen here. Thank you very much.